So what we started talking about last time was adding rational expressions last class. We started off with just them already having a common denominator, and then we looked at ones that don't have a common denominator. But what made those ones of a certain type is that they only had like one number in the denominator or one term. So just to kind of refresh your memory, like we did these ones, they only have, those are monomials. So what we're going to move into today is we're going to move into problems where you don't have a monomial, but rather you have a binomial, something like A plus B, so two things being added or subtracted together. Yep, those are unlike denominators. So, yeah, I put this in parentheses here, it says no factoring. We're going to start simple where we don't have to factor in the beginning, but a lot of times when you have unlike denominators, you do have to start by factoring them. But we'll start without that first. All right. So let's jump in. I'm going to rewrite it. You don't have to rewrite it. I like to see the original problem, but now I'm going to start doing stuff to it. And here's what I'm going to do. I want these denominators to match. Now, first of all, anytime you guys have binomials, I like to put those in parentheses. The problem won't necessarily do that for you, but I think it's helpful to do that. Second of all, I want to get these denominators to match. So the first thing I'm going to do is I'm going to multiply to match. Okay, so I'm going to multiply this side by x plus 5. And I'm going to multiply this side by x minus 2. Now, if you're taking notes, I would say either have the original problem written down and write it this new step, or use a different colored pen like I'm doing, because you do want to see what the original problem was versus what you did to it. Because when you look at this later on, you're going to just see a problem that looks like this and not really understand what happened. So either use different colors or rewrite two steps. I would encourage that. All right. So on this side, I put x plus 5 on the top and bottom. And this one, I put x minus 2 on the top and bottom. That way, they both have the same two binomials in the bottom, x plus 5 and x minus 2. Now they have a common denominator. Okay. So here, I would distribute. So that'll be my next step, is to distribute. Use red for this one. Distribute. So I'm going to take this 2 and multiply it in here on the top. That's going to give me 2x squared plus 10x. Same thing here. I'm going to distribute this 6, so that gives me 6x minus 12. Once again, these are binomials, so I'm going to put them in parentheses. I'm saying I recommend doing that. I'll wait for you if you're still catching up. Okay, so step 1, multiply to match. Step 2, distribute. Let's move on to step 3 here. Step 3, I would say, what we're going to do is we're just going to go ahead and combine these into one fraction now, since they have a common denominator. We have 2x squared plus 10x on the top left, minus 6x minus 12 on the top right, and we put all that over the common denominator. Okay. And for step 3, I'll put it up here because I'm going to have space on the side, but it's just to combine them together into one fraction, right? At this point, we probably should know what to do. What should we do at this point, guys? Change the signs. Yeah, we want to take that little negative there and distribute it into the parentheses, right? So that's going to give me 2x squared plus 10x minus 6x and plus 12. Both of these signs change. And then we want to combine our like terms. So 10x take away 6x is 4x. I'll circle those. And hopefully that's our answer. I'm going to put a box around it. All right, and I said hopefully, because as I mentioned, usually you don't need to reduce these, but sometimes you do. Let's see. It looks like we're happy. That's the answer. Notice also the bottoms are backwards, but that's okay because they're being multiplied, and when you're doing multiplication, order doesn't really matter. But there's the answer. All right. Now, let's say it's a multiple choice test. I'm pretty confident I did everything right, but I don't see my answer. Maybe it's possible that you can factor the top and then cancel something off to reduce, something to look for. But like I said, that doesn't happen very often, and so I don't really make a big deal of it. All right, let's do another one here, but we'll do it together. Let's go ahead and write down example. We'll call this guided practice 1. Guided practice 1. That guy. Same type of problem, though. I'm going to have you guys help me out a little bit this time. Once again, I would say either rewrite this for this first step or make sure you use different colors when you do the first step so you can tell what the original problem was. All right. So, Brittany, what do I do first? Yeah, multiply to match. So what does that mean exactly? Let's ask Adriana. I want to multiply to match these, so I'll ask you a specific question. What do I multiply over here? Yep. Whatever this other denominator is, that's what you're going to put over here. Oh yeah, I should probably put these all in parentheses once again. Haley, can I ask you what we would multiply on this side? Good job. Just the other one, right? So on the other side like that. So that's the first step. Multiply to match. What do I mean? We're multiplying, and now the denominators match. So we're good. Need a common denominator. Miles, what's the next step? Yeah, I'm going to use the word distribute, but that distribution is just basically a type of multiplication. So why don't you guys go ahead and do the distribution there, and I'll ask you what you got. And be careful. There's B's up here and there's 6's. Try not to get them mixed up. They look the same. And all that means is you're going to take the two tops there with the sign in between them. and put them over the common denominator there. All right, Shakir, what's next? We already, so by combining them, I put them in one fraction already. So what would you do next after we put them together like that? Okay, so what would you do first to solve it? That's right. Now, you don't do this every time. You only do this because there's a negative there, right, guys? So if there's a plus here, you don't change the sign. So it's going to be 20b squared plus 8b minus 2b squared minus 12b. All right. Vidal, what's next? So what would you do to simplify? So what would you put together? I'm just being specific. So like, tell me what two things that we could put together here.
20b squared and -2 squared.
Good. So so what I'll say is simplify is right, but a more specific one would be like combining like terms, right? So 20b take away 2b squared would be 18b squared. And then 8b take away 12b would be -4b. Let you guys just try one from beginning to end on your own there. All right, show me what you got. These are unlike denominators with binomials, but I put in parentheses here no factoring. That happens, but you may have to factor, and how do you know when you need to factor? Well, that comes from experience. So I'm hoping that at this point you guys can look at a polynomial and tell I should probably try to factor that. Whereas with these two things, there's nothing you could do to factor them. But when you look at this next problem here, when you guys look at this, I hope you're thinking, GCF maybe, box method. So you need to be able to recognize when factoring is possible. But we're going to go ahead and do this. This is example 2. And I'm going to call this unlike denominators again. But this time it's with factoring. And I'll show you what I mean by that as we go through the problem. But so it's very similar. Say that again, bud? Yeah, I'm sorry, I mean lazy, but DEN means denominator. If you want to write out the whole thing, that's fine. I just like to save time and abbreviate. All right, so on this problem, I'm going to show you something that you can do. And if you see the opportunity, go for it. But I don't think it's going to be like that on most problems. Do you guys see something we can do here right away? Something stand out to you? That's true. But before we do that, there's something else I want to do. We're going to do that too, but before we get to that, what would you simplify? That's reducible, right? Let's make the numbers smaller before we can begin. That way we have smaller numbers to work with. That you won't see that often, but if you do, go for it. Just simplify it. So 6 over 3 is 2 over 1. We may not see that happen again today, but if you just see it, do it, because there's no sense in having extra stuff there that you don't really need. Cheat here for a second. I want to look at the answer real quick. Okay. All right. Now, before you start getting a common denominator, what you want to do is factor. On this problem, it almost seems kind of silly. I won't go into why, but you do want to factor first. So let's begin by factoring first. So I'm going to start by taking out a GCF. Now, you may not always have a GCF to take out. So if you don't, just skip this step. But as you guys can see here on the bottom, I can take a 2 out of all three of those numbers. I could divide each one of those by 2. So I'm going to take a 2 out and put it here in the front. And if I divide each of those by 2, I'll be left with x squared plus 4x plus 3. So step 1 is going to be to factor. If you can, take out a GCF first. So Michelle recommended that to us a second ago. And then after that, Shakir gave us another recommendation. And that was, since this has 3 terms, we use the box method to factor that. So we have 2 over 1 minus 2 over 2. And I'm going to put 2 blanks here. And we're going to figure out what goes in those blanks. That's the box method. So let's do the box method. What goes here? Remember I took the 2 out? So after we took the 2, yeah, the x squared is going to go here. How about down here? Yeah. All right. So now let's fill in the box, right? What times what makes x squared? That would have to be x and x. What times what makes 3? That would have to be 3 and 1. Let's fill in the box. And we should always check our answer. These two should add up to make the middle number that we had. What was the middle number? It was 4, so we're good. That makes 4. So there it is. We have x plus 3 and x plus 1. That's the new step. The rest of the stuff on here is not new. So I want to let that soak for a minute in your minds, what we just did. So I had a weird thing happen here. Don't expect that to happen often where you can reduce, but if it happens, go for it. The main thing I want you guys to be aware of is you'll have to factor if possible. If you see a GCF, take it out. If you do the box method, do the box method. After that, the rest of the problem is pretty much the same as what they were before. So notice that this side needs all of that stuff to match. So now I'm going to multiply to match. So I need to put all 3 of these on this side. Kind of out of space, so I got to erase this stuff. Once again, I'm going to use different colors to kind of help me see where I left off. I like parentheses around my binomials. Say what now? Oh, it is a plus. Thank you. Guys, I put minus here. Those are pluses. Thank you, Cal. The original problem had a plus there. I changed it. Good catch. All right, so what I'm going to do then is I'm going to multiply the top and the bottom by everything. Whatever this side doesn't have, I need to put over there. So it's missing everything. It needs a 2. It needs an x plus 3. And it needs an x plus 1. Same thing up here. A 2, an x plus 3, and an x plus 1. Now they have a common denominator. This side over here, does it need anything? You could put a 1. You don't have to, because ones don't really do anything, but technically if you want it just to look right, like look the same, you can put a 1 there, but it's not going to do anything in the end. All right. So now we're going to multiply here. So let's do this first. X plus 3 times x plus 1. I'm going to use a box for that. But this is multiplication, it's not factoring. So this is the one where we start on the outside. X plus 1 and x plus 3. Now some of you guys who might be on your game might realize, Mr. Bailey, we already know the answer to this, but if you're not seeing it, it's okay, you will soon. But x times x is x squared. That's 1x. That's 3x. That's 3. So I've got x squared. Combine your like terms. And there's 3. So by multiplying these two pieces together here, I've got this now. You guys notice I'm only multiplying on the top as well, by the way? I don't ever multiply the bottoms together. Just so you know, you don't have to multiply the bottoms together. If you distribute 1, it's not going to change. Okay, so let's kind of like get our bearings here. What did we do first on this problem? We factored the denominator. We took it at GCF and a box method, right? After that, it's all the same. Multiply to match. Distribute. In this case, our distribution is like a box method, actually. But we still need to distribute. Instead of multiplying by 2 twice, what could I do instead? Oh, what? Yeah. So instead of multiplying by 2 twice, why don't we just call it a 4? 2 times 2 is 4, right? And just distribute that in there. So I've got 4x squared plus 16x. I have a 2 out here and a 2 here, and I put them together to make 4. Where did they come from? This 2 came from the beginning problem. It was a 6, but it got reduced to a 2. This 2 came from when I matched the denominators. It got another 2 on there. So one of them came from the beginning, one of them came after I matched. Oh, that's a 2. All right. Now what? Combine them together into one fraction, right? I know it's probably starting to feel a little bit overwhelming, but I want you guys to know right now all the steps I'm doing right now are the old steps. The only thing that was new was those first 2 steps in the beginning where we factored. I guess this box method to multiply here was a little new too for a problem. But at this point, we should kind of be relying on instinct a little bit based on our experience. So what would the next step be here? Combine the like terms together, right? So I've got a 4x squared, but there's nothing like it, so it's going to stay the same. I've got a 16x. That can be combined with that 1x there to make 17x. And then I've got a 12 and a negative 2, which makes 10. Okay, we're done. That's the end of it. So it's the same steps. Multiply to match, distribute, combine, but we have a new step in the beginning. It's factor. Okay, that factoring could be GCF or box or both. It doesn't matter. So let's go ahead and try a guided practice here. So go ahead and write down. Yeah, I guess we'll do this one. I don't like how similar that is, though. They're all got 6/3. My software is not very creative. Okay, go ahead and write this one down. This will probably be our last one for the day. Just all right. So, Damiani, what do we need to do first? We do need to factor first. Good. Cynthia, whenever you're factoring, what's the first thing we look for? Yeah, let's see if we can have, and there is one, by the way. This guy down here does have a GCF, so I want you guys to fill in these blanks for me. I'll give you a second, and I'll ask you what you got. By the way, before you do, I'm going to do this too. It's another one of those weird circumstances. That one can reduce. What would that become, you guys? 3/1x, right? So I'm just going to change it to 3/x now. All right, but go ahead and take out your GCF there. I'll ask you what you got in just a sec. So Amethyst, what did you take out? Good. And what was left on the inside? Good. All right. Thank you. Armani, what's the next step?
You're gonna times or multiply differences or distribute.
No, not yet. Not yet. Not yet. Let me see if Amaya might know. What's next? We want to factor using the box method. So I want you guys to factor this using your box method. So go ahead, I'll give you about a minute. And I'll ask you what you got. The rest of it's old. So, Robin, what would you have us do next? Yep, you want to multiply the denominators. Good. All right, so so Brianna, what will I put over here on this side? Now, I just want you guys to be aware that let's say this side over here already had an x plus 2 on there. You don't need to put an x plus 2. But anytime it's doesn't have one of the factors, you have to put them all. So you don't want to overdo it, otherwise you'll end up with more than you need. So I kind of wish we had an example where I already had like an x plus 2 here. So you'd say, oh, I don't need to put the x plus 2. It already has that. So just know that you only need to put what you need. Don't add more than you need there. Okay. So there's that.
I'm going to multiply the 3 and the 2 together here just because it bothers me with those two numbers being separated like that. It looks weird. I'm also going to put this x and this 2 together here. You don't have to do those things, but I think that's normal. So if you do that, you'll more likely end up with an answer that looks exactly like what they have in your choices. Okay. So now there's another strange step on this one that was kind of new to us. Michelle, what else do I need to do here? It's kind of different from the first set we did today. Like, what's the next step? Yeah, we need to put these together using the box method. So go ahead and do that. I'll ask you what you got in just a second. Go ahead and multiply those together using your box method. All right. Okay. So, Brittany, what did you get for your box method here? Good. Okay. The next step, you guys, would be to go ahead and distribute. So that gives me 6x squared plus 36x plus 48. The next thing would be to combine them together. So I'll put the two tops together now. And then I would combine like terms, and then we'd be all done. 36 and 1x makes 37. 48 and 40 minus 6 is 42. Okay, guys, that's where we'll stop for today. We have our quiz tomorrow, huh? Oh, it needs an X, huh? Oh. So, guys, what Miles just noticed is that I should have, but I did not. Should have put an X over here. So, Miles, I owe you some points. I'll make the corrections now. That will change things a little bit, though, in my final answer. Thank you, Miles. Good catch. But we do have our quiz tomorrow, you guys. So you got a study guide for homework tonight.
There's our corrected answer. Thank you, Miles.
Like you always cheat. You cheated last minute.